is addressing modes and some string processing related stuff. So let's just dive right in. So let me just actually start in C. Morning, Cole. I know, right? And not yet, it's a blank file right now. Okay, so let's just make a random string here, and nothing particularly fancy. So I'll just do, let's see, how about car, my string equals, you know, something like that. Nothing in particularly fancy. Okay. And actually, let me actually get rid of that for now. Okay, so let's suppose that I wanted to write a function that computes the length of the string, okay? Now, we don't really need to actually write such a function because the string length function does exist, but how would we do it if we wanted to? So if I wanted to do an int string length, well, here, let me do an underscore. Define the function there, and then we'll actually define it here. Okay, so what is this thing going to accept, right? If it looks like it accepts a string, but what really is it accepting? Yeah, pointer to the string. So it's the base memory address, whatever the first memory address of the string is, okay, whatever number that's going to be. And what would we want to do to scan through this thing in order to determine its length? Well, first off, we need some sort of counter. So let's just initialize that to be 0, because before we do anything, the string has no length, right? And then what would we do? What do we need next? No, because it's got the curly braces. So you say, why does it need it at 4, right? 4 is the placeholder for the name, the definition of the function, and then we actually define it down below, right? Okay, so, but I need some sort of loop, right? Because I need to scan through the string and say, all right, is the character that I'm looking at the null terminator, or isn't it? Okay, so I could do something like while my string of counter is not equal to the character 0, or sorry, the character \0. Okay, so what's the difference between the character 0 and the character \0? Yeah, \0 is the null terminator, which numerically is just the byte 00, right? It's all 0. Whereas the character 0 is whatever the ASCII encoded value of 0 is, which was like, oh, I don't remember, 40 something, but it not 0, point being, right? Okay. So while we, the counter entry of my string, and of course, since the counter starts at 0, what's the first entry of the string? It's at the 0th position, right? Because that's just the way we start counting, right? Okay, so, pardon, better late than never. Okay, all right, and so what do we do in this case while this thing is non-null terminator? Well, we just add 1 to our counter, right? There's nothing else to do in this case. And then the loop is going to continue running until such time as we do hit the null terminator, in which case we'll break out of the loop. And now our counter variable is equal to the length of the string. And so what should we do? Just return it. And that's it, okay? And then if I went up here and said, okay, let's do int L equals string length of my string, okay, and then we could do printf the length is percent I backslash n, and then we'll pass in L like that, right? Okay, good. So just silly function. And the way I've done this, though, and I've done this deliberately, because what we're about to do is look at exactly how we would do this or the same thing, but in assembly, okay? That I've deliberately written it as a function to which I pass a pointer to my string, and I accept back, in this case, an integer that has the length of that string, okay? So keep that in mind for when we keep going. All right, so let's run this thing and make sure it works. So what is the length of this string? 18, 19, 20, 21. Yeah? Look good? Okay, so let's just make sure we get reasonable answers. Let's see, examples. Let's go to assembly strings, GCC. Okay, good. So works. All right. So nothing particularly special there. And if you think about it, right, this looks a whole lot like your 2 upper or 2 lower functions in C when you did those. The only difference, of course, is that inside your loop body, you had some sort of if statement, basically, was the character between A and Z either lower or uppercase? And if so, then you modified it, right? Okay, so in that sense, right, this isn't that far off of what we've something you guys have already written. But how would we do this exact same thing in assembly? Okay, and this is going to be obviously what you guys will need to use for what's the well, you've got the recursion assignment due soon, right? What's the one after that? Yeah, mocking SpongeBob, right? So the mocking SpongeBob meme, right, started with where the text basically semi-randomly alternates between lower and uppercase, okay? And you know, this has become sort of fuel on Twitter, right? Even if it's not part of a visual meme, basically like, you know, anytime anybody proposes a social program, like let's spend federal money on X, and somebody's always like, but how are we going to pay for that, right? And then it's all upper lowercase, right? Okay, so why did I come up with that as the assignment rather than having you guys just do 2 upper or 2 lower in assembly? Yeah, because the 2 upper or 2 lower, I don't remember which one it is wholesale in the book. Well, what fun would that be to assign you guys a thing where the code is right there in the book? Yeah, it would be. Actually, you know what? I almost should have done that deliberately just to see how many of you guys actually noticed it was in the book. And yeah, okay. Anyway, so I came up with this instead. Now, I'm going to leave it to you guys to determine exactly what pattern you use for the upper to lower case, right? If you want to make it alternate, or if you want to make it like try and come up with some sort of semi-quasi-random sort of thing. That I'll leave up to you, right? Just do something that looks reasonable. But point being, how are we going to have to do it? Well, we have to do it by going sort of character by character through an array, or string in this case, and modifying characters as we go. Okay, so what that means is, how do we go through a string character by character in assembly, right? We know how to do it in C, and I think you guys will be pleasantly surprised to see that it's not actually all that, like, it's going to translate quite nicely into assembly. Okay, so that's our objective. Okay, good? Yeah. All right, so let's do the same thing. Oops, let me start a new file. Okay, but let's do it with ASM. Okay, so what do we need? We need a data section, we need a text section, we need global main, we need our main. Okay, we need, of course, store pair, x29, x30, stack pointer, -16. Breaking the law, breaking the law. Yeah. So how much was the ticket? Or did he let you off with a warning? You have a court date? Wow. Mm-hmm. Ah, see, that's what they told me, right? When I got pulled over for the expired registration, and then it caused a year of hell because the registration was not actually expired. The computer says it was, but the updated sticker was right there, right? And yeah, so it was like, yeah, it took me a year of fighting, and I finally had to go to court before I could, like, show a prosecutor basically, like, here's the date I renewed it. Here's a photo of the sticker on my car with the VIN number of the car, so you know it's my car. And here's the date of the ticket. And he looks at this and he's like, why didn't they just deal with it? I said, we've been fighting this a year. He said, this is stupid. Take this next door, it's dismissed. See ya. I had to miss a final exam because of that. Yeah. And then take it later. Yeah, it sucked. I know. So, okay. Anyway, so what do we need? We need our usual suspects here. Sorry, not LDR, move. Okay, so our usual suspects. Hmm? What now? Uh, it's a habit just to notate that it's an immediate. Yeah, you don't actually have to, but it's just a habit. Um, some assemblers actually are picky about that. So, um, for example, some of those assemblers actually are right, and if you don't put the hashtag, then it assumes that it's an actual memory address instead of an immediate number. Um, so yeah, RIP. Yeah. So again, yeah, it just depends on the assembler, and because I'm used to working with assemblers that do expect it, I just usually go ahead and put it here, just to cover my butt. Okay, so that's the usual stuff, right? And then I need to define, well, a couple of strings up here. So let's see, what do we need? We need our Wabash always fight strings. So let's do um, um, uh, we'll just say WAF, ASCIZ, right? Something like that. And then let's just do our format string. for the printing okay, great. So we've got our the string that we wish to process and the format string that we're going to be using for the printing. Okay, and so let's set up then the function. All right, and our function should go down here somewhere, and we'll call this, how about just length, right? Nothing special. Okay, so the length function is a subroutine. And in this case, is it a subroutine that's going to call itself? So do we have any sort of recursion stuff going on with this particular string processing? We'll have a loop for sure, but we don't need any recursion, okay? And so in this case, we could get away without doing the store pair, load pair in the beginning and the end of this subroutine. But just to be careful, I'll go ahead and do it anyway, okay? And so we'll do store pair and then at the very end, we'll load pair. Okay, we only truly need that, like I said, if the function is going to be recursive or calling other functions, because then we would need to sort of keep a full trail of breadcrumbs to get back to the main routine. Okay, so okay, so we got that. Now, we need to initialize a counter to be 0, okay? And we need to obviously load in the address of the string, okay? So what is the base address of the string? Now, I don't actually know the number, but how am I going to load this data into a register? Yeah, I need to load the pointer. Okay, so how do I do that? Right? So that's my X0 would then contain the address of the Wabash Always Fight string. Okay, whatever it is. Okay, and then, okay, so like if we go back to the C version, right? What did I pass to the function? I passed to it the pointer to the string, okay? So if I'm going to pass a parameter to a function, where should that parameter, that single parameter, go? Okay, so if I pass parameters to functions, where do the parameters have to go? What's the convention? X0 through X7. Now in this case, we only need 1 because we're only passing a single pointer, okay? So I need to put that in X0. Now, do I have to? No, but that's just the function calling convention, and so we're just going to stick with it because that's how they're all written. So damn it, just shut up and do it, okay? Okay, so I need to pass the address to the string, and then what's going to come out of this will be the answer, and it'll be an answer in, well, in the example I wrote, what would it be in? Where would the answer come out? W0. Okay, why? Why not X0? Yeah, because I defined it as an int, not a long int. Right, so it's 32-bit, not 64-bit. Okay, whatever, right? Okay, so once I've put that in, then I need to branch and link to my length function, which is, of course, right here. Okay, and then when I come back from this thing, in this space here is where we'll get the answer back and then put, print it. Okay, all right, so good? All right, so now the meat of this, right, is the actual, how do we do the length? Okay, so we just got in the address of the string, and that is sitting in register what? X0, okay? And I need a counter, right, that I will keep track of to count the length. What was the initial value of the counter before I did anything? 0. Okay, so I need to load 0 into a register. Okay, let's put it in register 1. Okay, fine. Okay, so this initializes my counter. Okay, now in C, we did a while loop, right? Okay, so what we need to do for that while loop, so what was the while loop in C? We looked at the counter element of the string and compared that to the null terminator symbol, okay? So in our case, we're gonna be comparing something to the number 0, okay? Because what is the null terminator? Just 0, 0, right? It's a byte. Okay, so what I need to do here is how do I load a thing out of memory into a register, but I only want to load a single byte, not a full 32 bits or 64 bits. Okay, if I wanted to load an entire 32-bit or 64-bit number, I would use LDR or maybe move, depending on if it's an immediate or not. Okay, well, so how do we move a byte at a time is basically the question. Well, what do you think? Wouldn't it be nice if there was an instruction for that? There is, okay, and it's not shockingly called LDRB. Okay, so load register with a byte. There is also load register, or LDRH for load register with a half word, which is a 16-bit quantity. Okay, so you can do an 8-bit quantity, a 16-bit quantity, a 32-bit quantity, or a 64-bit quantity, right? Those all make sense. Okay, okay. But for, we want the byte version here because we're of course processing a string. Strings are stored in ASCII. Each character in ASCII is 8 bits, so that's perfect. Okay, now this part is gonna maybe kind of drive you guys a little bit nuts. So, and this is, I maybe made a reference to this last week, right? You order something from Amazon or whoever online, right? And it finally gets to you, and then what do you notice? Like what inevitably happens? It's in a package, a box, like egregiously larger than the item that you were getting, right? So it'd be the kind of thing where, you know, you order this calculator and the box is the size of the table or something, right? It's just ridiculous. Okay, so that's annoying, right? But does the calculator fit into that box, that giant box? Yeah, of course it does. It would have been much nicer if they used a smaller box, right? But they didn't. Okay, so the situation for where we put this byte is kind of a similar question, okay? So we want to take a byte of data and put it into a register. And of course, it's an integer register that we need to move it into. So should we put this into an X register or should we put it into a W register? Well, putting it into an X register is like using the gigantic box for a tiny little item. So let's put it into a W, okay? And that is the convention. Load byte, you always put the thing into a W, never an X. Okay, so it's sort of the way Amazon should be. It puts it into the smallest package that can fit it. Okay, is that all right? All right, so which W register should I put it into? Oh, and I just noticed an error because what's my X register? What should I have done there? Should be X1. Why? Because the pointer's in X0. Okay, So I need to put this byte into some register, and which byte am I going to put it into? How about W2? Okay. All right, so W2 will be the destination, right? Because I've already used register 0 and 1. Now I'm up to 2. Okay, so we're cool with that. Yeah, okay. Now, that's the destination, W2, but what am I putting there? The pointer is in the register. It's in X0. I haven't actually put the pointer on the stack. Well, I don't really know, right? But what I want to do is say, okay, I want to go out to memory to the base address of the string, and whatever byte I find there, that's what I want to load in. Yeah? Okay, so what I want to do here is what's called indirect addressing. Okay, if I didn't put the brackets there, what would it do? It would go out to X0, okay, and, well, I couldn't really do that. Yeah, okay. So let me rephrase. What the bracket does here is it's an indirection. Okay, so X0 has a pointer in it, yes? Okay, so I'm going to go out to memory address X0, and whatever byte I find there is what I'm going to load into W2. Okay, so normally with the load or store, you have to specify an actual memory address of where to go get it. Okay, here I've not actually given it a memory address. I said, hey, the memory address that you need is sitting over there in that register. Go get the address from that register and then go out to memory. Okay, so you see how we've been sort of one layer abstracted or indirected? Yes? We? Okay, so that thing, the W2, will now have the byte, okay, for the very first character of my my thing. Okay, does that make sense? Okay, now, once I have that, what do I want to do? Okay, so let me go down here and let me make an end thing. Okay, for reasons that'll become clear in a minute. Okay, so I've loaded in a byte. Now I need to do a comparison. I need to say, is this byte equal to the byte 00? Okay, it either is or it isn't. And why I care about 00? Well, because that's the null terminator, right? We're still working with the string. Okay, good. All right, so what instruction do I need to do a comparison here? CMP, okay. What would be maybe slightly better in this instance? That'll work, but we can do it in a single instruction rather than two this time. Well, we're comparing whether or not something is 0, right? So what comparison instructions work specifically with the number 0 as one of the things you're comparing to? CBZ or CBNZ, and which one we pick just depends on which way we want to do the logic. Okay, so in this case, we want to go to the end if we do have the 0. Okay, so do I want CBZ or CBNZ here? CBZ. Okay, what register am I comparing to the number 0? W2, that's the contents of my, that's where the byte that I'm examining is sitting right now. Okay, good. All right, and where should I go if the branch takes place? end. Okay, so if null terminator finish function. Okay. Okay, for reasons that'll become clear in a moment, I'm going to put a loop label right there, okay? Because what are we going to do when we get to the second letter and the third letter and so on? We still need to load in those letters, and we still need to do the comparison, okay? Okay, now, what is the loop body assuming that the branch did not take place, okay? So the thing I just loaded in was not the 0 character. What should I do to my counter? Add 1. Do we do anything else in this case? No, because all I'm doing is counting the length. Okay, so I need to add, where did I put my counter? X1. Okay, you know what? I'm going to change this to W1 because I think I defined the format string with an int, not a long int. Okay, same difference, right? Okay, but what I'm going to do, right, is I'll just increment the counter. Okay, and then what do I do here? What do I do after I've incremented the counter? Then I need to start the whole thing back over again, right? So I need to branch back to the loop just to go back up to the top. Yeah, loop is right there, right? Okay, good. All right, so let me get rid of some of this space. Okay, so if I were to run this right now, well, we still got a few things to fix, okay? I claim that if we ran this right now, it wouldn't work. And the reason it wouldn't work is because we would get stuck in that loop and we would be in that loop forever. Why are we going to be in this loop forever? I'm sorry? Yeah. No, because that would happen right here. So if the byte we're looking at is null, then we go to here. Okay. Well, we never load another register, but really, what do we never load? I'm sorry? Another character, right? So what is X0 in this case? That's the address of the first character. If I want the second character in the array, it's 8 bits or 1 byte down from X0, right? So X0 is the base memory address. What's the next byte over? It's whatever's in X0 plus 1, right? Does that make sense? Okay, so we've got two options here. And actually, you know what? I'm going to change this back to an X. I'm sorry. And I'm going to go back up here and I'm going to make this a long int. Okay, so our two options are thus. We could either, so what's in X0, right? It's the pointer. That's just a number, right? If I add 1 to that, what does it now point to? It'd be the second letter. And if I add 1 to that, then I would be pointing to the third and so on, okay? Okay, so I could just add in there, right when I increment my counter, add 1 to the value that's sitting in X0. That would certainly work, okay? What's perhaps the downside to doing that? Okay, so if I add 1 to the contents of x0, however many times is needed, okay, that would certainly work, but what's maybe a downside to doing that? No, because it would branch before we'd hit that, okay? So that's cool, right? We don't have to worry about that. But what would happen to the pointer? Would I have known, like, would I have destroyed the information as to where the string started? Yeah, okay. And so for that reason, I'm not going to just add directly to x0. I'm going to do a second layer of indirection. Huh?
So let's go.
Let's go, right? Because, well, how much do I need to, okay, so this is, let me draw a picture on the board here, right? So if I've got, right, my string, and obviously it keeps going, right? And x0s is pointing to that memory address, okay? Do I have a thing that is counting 0, 1, 2, 3, and so on? What is it? It's the contents, in this case, of x1 that I'm using as my counter. Okay, so what I'm going to do is I'm going to change this load byte, and I'm going to add that. Okay, so what this does, that second thing, in this case x1, is an offset. Okay, so this is base plus offset addressing. Okay, now, when I first start this length function, what is the value in x1? It's 0, okay? So if I go, what that instruction that I'm, the line that I'm on there, it says, okay, go to x0, whatever's there is a memory address. Add whatever's in x1 to that address, go out to memory, find the byte there, and pull it into W2. Okay. Now, at the very beginning, is this any different than what we had a moment ago? No, because what does x1 start with? 0, because that's how I initialized it. Okay. However, when the loop runs a second time, what is x1 now? It's 1. Okay. And so that same instruction will load in every single letter, and all I'm doing is incrementing x1. I'm never changing the base, the pointer. Yes. Oh, because I'm an idiot and I should have changed those to x's. This should have been x. Sorry. Yeah. Because I was being indecisive as to whether I wanted w's or zero or x's. Okay. Okay. So that line 26 there is doubly indirected. Okay. So it's an indirect base and an offset that's stored in a different register. Okay, so does that kind of make sense? I know that's a lot of indirection for 8:30 in the morning or whatever time it is. Okay, is that good? So the brilliance here is that we already needed to have a counter, right? And so we're just using the counter actually for two purposes. One, because we care about whatever the number is. And two, we're using it as the offset from the base of the string. Okay, now, this sort of idea would be useful because let's say, for example, you were scanning through an array of numbers. Well, what would the array of numbers be? Well, it depends. What kind of numbers? Let's say you had an array of integers. Okay, if you were scanning through an array of 32-bit integers, what would your offsets have to be? They'd have to be a multiple of 32 bits, right? And in our case, why is it that we're incrementing by 1 each time? And 1 byte, well, it's just because the strings are stored in ASCII and each character in ASCII only takes a single byte. Okay, so no big deal there. Okay, is that cool? Okay, so that one change is going to mean that we never end up with a endless loop here, unless we give this function a garbage pointer, right? Because that loading thing is going to load in the whatever letter, whatever entry in the string we're currently looking at, and then increment the counter if needed. And if the counter doesn't increment, that means we're finished and we're going to the end anyway. Okay, now, what else do I need to add to my end thing here? 2 things. I need to add a ret to get back, but also, where is the value that I was counting here? Where is the counter stored? It's in x1. Where should I return the answer? x0. Okay, so if the thing I want to return is currently sitting in x1, but the calling convention means it needs to be in x0, where do I need to put it? What do I need to do? Just to move it from x1 to x0. Okay, so I'll do move x0, x1. Okay, and then after I pop the stack, I'll do a ret. Okay, so is that good? Okay, now, the length function runs, and what is it returning back up to here? It's returning the length, and where is that number, the length? x0. Where do I want it for printing? No, I want it in x1. Okay, so what do I need to do right when I come back? That. Okay. I also need to, oh, no, I have to do this second, not first, obviously. The reason I have to then move it back to x1 is, well, what needs to be in x0 for me to print? A format strings address, okay? And so I just put that in x0. And you see why I did line 16 after line 15? Why did I have to do it in that order? Right, exactly. x0 is the answer that I need to keep track of. And so I need to move it into x1 before I put something else in x0. Yeah? What happened to you? You should lay off the blow, man. No. So, okay. All right, so then what do I need to do? Actually print it. Okay? And was there anything else we wanted to do in our program here? Nope, should be good. Okay, so questions about the structure before we assemble and test and make sure it actually works. It's all good? Questions, questions, preguntas, fragen? 9? You have 9 questions? Yes. Yes, you could have in this case, okay? And the reason you could get away with it is because our function never calls any other functions, and it's not recursive, okay? So we could have gotten away with leaving the thing in x1 because we knew we were going to have to move it there eventually, okay? But that's maybe bad practice long term, okay? Because how do you know that you're not going to end up writing a subroutine that is going to call some other subroutine, in which case the registers might get all jacked up, okay? And furthermore, and this is why we have to obey the calling convention, how do you know that you're not going to use some subroutine that some other dude has written for which you don't even know what the code looks like? Okay. For example, printf, right? Printf is certainly a function that we didn't write, that we make use of, and so we have to obey the calling convention because whoever wrote printf also obeyed the calling convention. Okay, that would also be needed. Like, what about, you know, and I almost did this as the example instead of the length counter. What about if I wanted to print every character one at a time? Well, then my printf would be inside the loop, and I would definitely have to be careful there because I'd be going to subroutine to subroutine. Okay. Okay. So yeah, we could have gotten away with it in this case, but I guess what I'm trying to do is sort of show you, like, what would we do in the more general case? Because when you do that, you'll thank me. Okay. All right. So does Arthur's question make sense? Our lawbreaker. Hmm. I don't know. You know, what do you guys think? Is it violation of the gentleman's rule to be getting tickets? Huh? Yeah. So we'll just call it a little bit of civil disobedience. How about that? Actually, on that subject, I read probably, it's not the greatest line from a court case, but it definitely ranks up there as pretty good. So, you know, all the morons that decided to, like, invade the Capitol on January 6th and what was definitely a coup. Uh, there's, huh? Yeah. There's one dude there's a picture of him smoking a doobie in the rotunda, right? And he was getting sentenced. He pled guilty to some misdemeanor or something or another. And part of the conditions is that he's not allowed to travel internationally for some period of time. And so he asked a judge for permission because his family's planning like a Christmas getaway to England. And he's like, can I have permission to do that? And the judge was like, you know, as the defendant's conduct was one toke over the line, motion is denied. So, yeah, it was pretty good, pretty funny. So, yeah. All right, so let's assemble and run this thing and see what happens. All right, so let's see. So we need to assemble strings2.asm, output to strings2. And I'm going to go ahead and use the debugging flag here so that we can pipe it through GDB if we want. And GCC. Okay, there it goes. It worked. Okay, good. So exact same function, basically, but this time a la assembly. But let's go through GDB here and just kind of make sure that we understand how this double indirection is working. Okay, so we are about to execute the length instruction, so we're about to jump down to there, and we just loaded x0 with the base pointer of our string, which is blah, 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 483028, okay, whatever it is, who cares? Okay, so now let's step through and go on to our length function. Okay, so we store pair, we initialize our counter, okay, no big deal there. And I'm about to execute this, so let's look at, okay, so info RW2. Okay, so W2 just got loaded with the thing at the base address offset by 0. Okay, and so if I examine the memory, What was the base address? 483.028. Okay. There's our string, or at least part of it, in memory. Okay. So what's at the base address? What's the entry at the very, very beginning? 483.028, which byte am I looking at? It's the 57, right? Because remember the order. Okay, what is 57 hex or 87 decimal? What should that be? Should be the ASCII character for the capital W. Okay, so one of you guys, since you got your computers open, pop open an ASCII table and double check that that's in fact the capital W. You guys don't keep ASCII tables just lying around? Yeah, yeah. 57 hex or 87 decimal. Yeah, it's capital W. Okay, and that makes sense. And then what's the next character after that? The 6-1. That's the lowercase a. And what's after that? 6-2. Yeah, the W, the lowercase b, and then the lowercase a, and so on, right? And the rest of the string is, so let me actually expand our examination of memory here so that it's, okay. Is there, do I need to find somebody a gentleman coin? Huh? Yeah. At least he can grow it. Yeah, exactly. Okay, so anyway, so what do we see in memory there? Well, we've got the Wabash always fights, and how many characters did we say it was? 21, I think. So it's really 22 because of the null terminator, right? So we've got 4, 8, 12, 16, okay? And then here's 20. There's the 21st, which happens to be 2-1 in this case. That's kind of coincidental that the exclamation mark is the, yeah. And then there's our null terminator, right? Okay, so what's all this other stuff that's after it? Just garbage, right? Who cares? Okay, but that makes sense, right? Okay, now let's step through this one more time so that we get to come back to our loop once. Okay, and all right, so I increment my counter and I go back up to the loop, and now let's look at what x0 is and what x1 is. Okay, so what memory address am I about to pull from next? Memory address, blah, 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 0 to, well, what is x0? 028 thing, okay? So that's the number that's in it, right? But what does that represent? That is the base address of my string. Okay, if my counter is now 1 and I'm about to execute this command, what address am I going to be loading a byte from this time? Hmm? 1 to the right of what? What is right? Okay, what's in register X0? 483028. What's in register X1? The number 1. Okay, so what does that instruction that I've highlighted do? Takes the address X0, offsets it by X1, and that's the address we go to. So which address am I going to go out to? 483029. Because the last time I checked, 8 plus 1 is 9. Yes? Okay. And if I were to loop this again, what would it be the next time? 028, 029, 02A, good. 02 B, C, D, N, and so on until I hit the null terminator. Okay, because I'm going through character by character through my array here. Okay, does that make sense? Yeah, so the double indirection here kind of making sense? Yeah? Okay. Right. All right. Okay, so let's just continue. Well, here, let me go through it one more loop. Right, then it's 2, okay, and so on, right? All right, so let's just continue, and then bam, the length is 21, and we're Gucci. Okay, so that just ran through the rest of the program. All right, make sense? Okay. And once it hit the null terminator, it branched to, so this guy here, once this is true, we jump to the end, which swapped the registers, popped the call stuff back off the stack, and returned us back up to here. We then moved them again, got our printing string ready, branched to printf, and then the program's done. Hmm? Oh, yeah, the format string. Yeah, that's just the standard kind of thing that we've used before, right? Because to print anything, right, you need a format string and then possibly data that gets replaced in where the percents are. Yeah, and by the way, if you ever need to print an actual percent character, you use \%, and then it fixes that so that you can actually have a percent symbol. Yeah. Mm-hmm. Ah, yes. So, what do you think the second thing we were going to do today was? Talk about Scanf. Okay, excellent point. All right, so let me save a copy of this. Okay, and let's modify this to also use Scanf. Okay, so what would this enable us to do? Well, what does Scanf allow you to do in, well, when we did this in C? What was the whole point of using Scanf? Take in some sort of input. Okay, so I'm going to change this, okay, this WAF thing. I still need my format string for printing, but scanf also needs its own format string because I need to tell it what kind of data is coming in. So let me call this format2. Okay, and I'm going to make it %31s. Okay, why? Well, what's the S mean? String. Okay, it's going to be accepting a string as a thing in ASCII. Okay, the 31 here does what? Limits it to 31 characters, and so adding in the null terminator, that means 32 bytes. Okay, good? Now, all right, so in order for me to then do scanf, so that's going to come here. All right, when we did this in C, what did you have to give scanf in order to function? Okay, what did you have to pass to that function for it to work? Mm-hmm. Well, you clearly had to pass it this format string so it knew what kind of data was coming in, right? That's fine. But what else do you need to pass it? Where to put it, okay? And in the case of when you do this in C, you just, where to put it, you defined a string of 31 characters or whatever and just said, hey, put it over there. But what the compiler really did was it pre-allocated 32 bytes on the stack where the answer, the data that comes out of scanf is going to get placed in memory. Okay, so we need to allocate 32 bytes for this string. And we need to put that 32 bytes somewhere on the stack. Okay, so if I want to expand my stack, what I do is well, actually in this case, want that. Okay, so what is this instruction doing? I'm adding what to what? I'm adding negative 32 to SP and putting the result where? Back in SP. So I'm updating it. Okay. All right. Now, why 32 and what is SP? SP is the stack pointer, and why minus 32? Because I need 32 bytes. Okay. Let's say I needed 37 bytes. What would I need to minus 48 would be the minimum, because it's got to be a multiple of 16. Okay, and that's a hardware thing. The stack pointer has to be a multiple of 16. Offsets from it can be whatever you want, but yeah. Okay, so I need to pre-allocate this memory data on the stack. Now I have a place for scanf to put my data. Okay, and so what do I need to pass to scanf? I need to pass it a format string and I need to pass it the place it's going to put it. Okay, and where am I going to put it? Well, I'm going to put it starting at the stack pointer's address, because in this case, the stack pointer, when I subtracted 32 from it, that allocated 32 bytes, and so the stack pointer is the base address of where I can put this data. Okay, is that okay? So what is the convention for using scanf, right? What do I have to pass to it? I need to pass to it the address of a format string and the address in memory where the output is going. Well, the address of the format string is whatever the address of the format string is. And where am I putting the data? I'm putting it at the stack pointer's location and up. Okay? So I need to put the stack pointer's value into register X1. Okay, because yet again, what's the calling convention? X0's got to be the first input, X1's the second input, X2 is the third, and so on, right? So again, I'm obeying that calling convention. Okay, so once I've got these two guys ready, I can now use and call scanf. Okay? Okay, is that all right? Okay. And then what's the other thing that I need to do here? I no longer have a string called laugh. Well, yeah, but I'm passing this to the length function. So what do I want to put here? I don't want LDRX0 laugh. I need to move the stack pointer to X0 because that's where my string is. Okay, because there is no more string called laugh, right? Now it's whatever I typed in. Okay, is that all right? Okay, do we have to change any of the rest of this? Hopefully not, but there's one instruction we need to add, okay? The size of the stack when your program starts should be the same as the size of the stack when the program ends, namely 0. Okay, so the very first instruction expanded the stack by 16 bytes. Then I expanded it by a further 32 bytes. So what do I need to do at the end of the program? Yes, but I'm going to do it. Oops. Yeah. I'm going to do it exactly the way I did it before, but of course in reverse order, right? So could I have subtracted 48 with the store pair instruction instead of doing minus 16, then minus 32? I could have, yes. Okay, but maybe it's better to do it as I go and think about what I'm doing before I try and do too much at once. Okay, yes. No, Scanf is like printf. It's just part of the C standard library. Yeah. So it's taking whatever the value of the stack pointer is, okay, and putting it in X1. It's just making a copy of it. No, not the length. It's where the data is going to go. Yeah, it's the pointer to where the string that's coming in from scanf needs to be stored into memory, right? Because what do you have to pass scanf? What kind of data, that's a format string, and where to put it. And so the where to put it is I want to put it on the stack, starting at the stack pointer. Okay, after scanf. Okay, yes, because the stack pointer right now is where my string is located. I need to put that in X0 because what's the next instruction? Branch to my length function. Well, where is the pointer to the string need to be for my length function? Because that's the calling convention and that's the way we wrote it. The stack pointer? Because scanf needs 2 inputs, not 1. Right? What is its first input? The address of the format string. And the second is where to put the scanf data. Right? That's why I put the stack pointer in X1 before scanf, because X0 was the format string's address. Right? And that's just the order they have to go in for scanf. I didn't choose that order. Right? Okay, so what kind of data, where are you putting it, branch to scanf? Here, where is the data located that you're passing to the length function? Right, again, it's all the calling convention. Okay, so this should work now because I put this there. Okay, so let's test it. All right, so let's do okay, what is it doing right now? Yeah, it's waiting for me to type something. Okay, if I wanted to make this program a little bit more bougie, what would I do? Yeah, I'd say like, please print something, right? Okay, good. All right, so Wabash always fights. Womp womp. It is, but it's also right. Yeah, it is. It is. Okay. So scanf, unless you tell it otherwise, and I forget off the top of my head how you do this, it stops when you hit a space, okay, or a carriage return. We can turn that off. There's basically in the %31s, we need to add something there that basically says ignore spaces. I just don't remember off the top of my head what it is. I'll look it up. It's the 31 characters. So that, well, that's the maximum that it will accept. So if I typed, for example, so if I reran this and did like, right, way more than 31 characters, it still tops out at 31.
How big can this number, how big can your percent blank SP?
I mean, as big as reasonable. It could be megabytes worth of data. You just have to sit there and type for a little while, right? So I picked 31 here semi-arbitrarily because it's enough to get the point across. Okay, 31 characters means 32 bytes because you got to leave room for the null terminator. And yeah, I mean, but like, look, if we can do it for a string of 31 bytes, could we do it for one for 31,000 bytes? It's the same shit. It's just more data. Okay, yeah. Okay, so let's go back over here. What was it? Caret backslash. All right, caret is this one, backslash bracket in that. That? Okay, let's try it. I did. Sweet. Okay, thanks, Cade. You get a cookie. Yeah, okay. Yes, bestow Cade a gentleman coin. Yes. Okay, so now the length is 21, which of course matches what our, yeah. Okay, so now that we've done that though, let's go into GDB and see how Scanf is actually storing that data. Okay, so let's do this, break main, let me step, oops, sorry. Okay, so I'm about to execute this. And just before I do it, okay, what do I see? Well, what is my stack pointer? It's blah, 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 010. Okay, I've expanded the stack to accept data from Scanf, but I have not yet put anything there. Okay, so if I step, okay, it's now prompting me to type. Okay, and so now if I look back at my stack, the stack pointer is still the same number, but now look what's in memory. Okay, starting at the stack pointer. Well, do we recognize this? 576162617368204 blah 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 blah. That's Wabash always fights. Right? So that's where it was. We put it on the stack by allocating an appropriate amount of space on the stack and then telling Scanf, hey, put it over here. Okay, now one last tiny thing before we quit. What happens if you are sloppy or careless or whatever, and you don't end the program with the stack the same as it started? What's probably going to happen? You're going to get a seg fault. Okay, so if you get a seg fault when you run your program, the most likely explanation is that your stack is not being expanded and contracted symmetrically. Okay, so if you get a seg fault, that's the first place to start looking. Okay, now there could be tons of reasons why that's happening. It could be that you're, I mean, it's probably, well, actually, it's all going to come down to you screwing it up, right? Right. Every error is you screwing it up. It's the arm, yeah. Okay, so, right. Yeah, if it was too easy, then yeah. Okay. So if you run into a seg fault, double check all your stack instructions and think through it. Okay. All right, Gucci. All right. So scanf and string processing. Wow, this is great, huh? To the code.
Was it you that said that, that like NASA or something still uses floppy disks? Well, they must have just